Hi everyone. So welcome back to Stats. So for today, I'm going to review some of the content from the last 4 weeks and go over the format of the second quiz. So let's jump into that. So first of all, the format is going to be almost exactly the same as the first quiz that we took before the break, except for it's going to be on Moodle. So it's a quiz on Moodle rather than in person, obviously. So 25 multiple choice questions and 2 short answer questions worth 5 points. So you can study for the second quiz the same way as you did for the first quiz. The way I'll be wording the questions and things of that sort will be very similar. So it's open book, so you can use the textbook, and it's open notes, so you can use your notes. You can also refer back to any of the YouTube videos, including this video if you'd like, because all the example questions I'll be showing you will be different from what is on the actual quiz. So it is open from Tuesday at noon next week until Wednesday at 10 p.m. next week. The idea behind that is if you have any technical issues with the quiz, or if you have a slower internet connection, or if Moodle slows down or whatever it might be, this gives you time to submit the quiz with a lot of time to spare if any issues come up. That being said, I would say you want to avoid waiting until the last minute to do the quiz for sure, because then you might run out of time. And if it's, late on Wednesday night, I'm not necessarily going to still be awake to help you with any quiz issues. So I would say choose a time where you're not going to be distracted for at least an hour, maybe up to an hour and a half, where you're going to be able to dedicate all of your time to working on the quiz. You can also come back at a later time and continue on with the quiz like you do with your weekly assignments, but make sure that you save any work that you've already done. Also keep in mind that you can only submit the quiz once. You can't do reovers, so make sure that the answers are the final answers that you want to give. I will be available over email if you have any questions while you're working through the quiz. I just might not respond to them right away, especially if it's like 2 a.m. on Wednesday morning, for example, but I'll do my best to get back to you in a timely manner with those. And there's no timer for the quiz. As long as you have it done by Wednesday at 10 p.m., that's fine. All right, so for chapter 8, that was the programming chapter. So there's only going to be one multiple choice question from chapter 8, and that is going to be a question about how scripts work in R. So other than that, you don't really have to know much for chapter 8. For chapter 9, there's going to be 4 multiple choice questions. And what this is going to cover is some of the basic information about probability and some of the background on the type of statistics that we use. So you'll want to know the difference between descriptive statistics and inferential statistics. You'll also want to know the difference between Bayesian and frequentist approaches to statistics. Know what a probability distribution is, and if I ask you an application question trying to understand what a probability distribution is, you should be able to do that. And you should also know what a probability density is if I ask a question about that. For chapter 10, there's also 4 multiple choice questions that come from that. So for that, concepts that you should know the law of large numbers. You should know the central limit theorem. You should know that you are, when you're doing inferential statistics, trying to estimate population parameters, so things like the mean or the standard deviation or the median or whatever it might be in the population. And what you use is the statistics from a sample, and know that population matches up with parameter and sample matches up with statistics. You should know how to interpret a confidence interval if I give you that information. For chapter 11, there's going to be 6 multiple choice questions. So you should be able to know the difference between a research hypothesis and a statistical hypothesis, know the difference between a type 1 error and a type 2 error. You should know what a test statistic is and what a sampling distribution is. You should know what p-values are and how to interpret a p-value. You should be able to make a decision if I give you, a test statistic and a p-value, know what type of decision that you'd make under that circumstance. And also know what power is and how to interpret power. For chapter 12, there will be 4 questions from that. So For this, you should know what the null and alternative hypothesis would be for a chi-square analysis. You should know the difference between the two main chi-square analyses that we talked about, the goodness of fit chi-square and independence chi-square. You should know the assumptions of chi-square tests, including what type of data you analyze with the chi-square and what is typically assumed with a standard chi-square test. And you should know about different chi-square tests that are used when it's a between subject and a within subject model. So there also will be one short answer question where I'll give you some output from R from a chi-square test, and you should be able to interpret from that, for example, whether the results were significant, be able to explain to someone who doesn't know a lot about statistics what those results mean. All right, chapter 13 on the ZNT tests, there will be 6 multiple choice questions. You should know the difference between a single sample Z and single sample T test. You should know the difference between the 3 main T tests that we talked about. You should know what an alternative and a null hypothesis would be for a T test if I give you an example. You should know the typical assumptions of T tests, know what degrees of freedom are and how they apply to T tests and how you interpret T tests. And also you should know how to interpret a Cohen's d value, right? And then for this, there also will be short answer questions. So similarly to the chi-square analysis, I'll be giving you some output for a t-test, and I'll be expecting that you'll be able to understand and interpret that information. Okay, so I'm going to go through 5 different example questions here. So I'll ask it, and then I'll leave a little bit of time for you to try to guess. You can feel free to pause the question if you want to have some time to think about it, as this might be a good way to study for the quiz. So for the first question, which of the following is an example of inferential statistics? I'll give you a few seconds to do that and wait for that to pop up. All right, so the answer here is B. Estimating who will vote for a candidate based on a sample of 500 US adults is inferential statistics, because inferential statistics means that you're trying to understand something about a population based on a sample. So here we have a population who will vote for a candidate in general, and we're basing that on something that we're looking at in a sample, which is 500 US adults. So it's not all US adults, it's just part of the population. All the other examples are examples of descriptive statistics, where we're trying to just understand something about our sample, so just describing the data that we have, or it is a population parameter, where we have all of the data available, for example, for all the days of eating calories or all of the heights of people in the US, in which case we're not making inferences about the population, we're just measuring what's in the population and describing it. Right, so just a sec, Raja is wanting attention, so I'm just gonna pick him up here. All right, you can be in the video. I wasn't gonna have you jump into the video, but I guess you wanna study as well. All right, so now Raja's gonna help along. You didn't want to be in the video a few minutes ago, and then I didn't want him in because he was jumping around. Now he wants to be in, so typical dog. Anyways, so question number 2, and I'll just move this out of here quick. Imagine that there's a situation where there are 3 possible outcomes. You either get a red card, a green card, or a blue card. So you know the probability of a red card is 0.20, probability of a green card is 0.20. What is the probability of drawing a blue card under the circumstance? And again, give you about 10 seconds to try to figure this out, but also feel free to pause it if you want to have a little bit more time to think about it. Your bow tie is all messed up, Raja. All right, so the probability here is 0.60. So according to Professor Raja, that's because if you look at the total probability for all outcomes, it's always going to be equal to 1. So if you know the other 2 possible outcomes, the third outcome has to be what's left over. So if you add those 2 probabilities up, it's 0.4, and then there's just 0.6 left over here. All right, So question number 3, which of the following would reduce type 1 errors? And again, give you a few seconds to try to give your best guess at this one. All right, so you would reduce type 1 errors if you decrease the critical value for your p-value. So the critical value is the cutoff point where you decide if there is, you're going to retain the null hypothesis or you're going to reject the null hypothesis. So if the p-value needs to be lower for you to reject the null hypothesis, then that's going to reduce type 1 errors, because again, type 1 errors are when you reject the null hypothesis when you actually should have retained it and assume that there isn't a difference. So if in the population there really is no difference. Right, so for question number 4, what is the default null hypothesis for a chi-square goodness of fit test? And in answering this, remember that this is specifically for the goodness of fit type of chi-square test. So again, give you a few seconds to work on that. Right, so with the chi-square goodness of fit test, the default is that the null hypothesis is that every option for all of the categories that you have listed occur with equal probability. So with the example of whether it's clubs or spades or hearts or diamonds for a suit of cards, the default null hypothesis would be that each of those 4 suits occurs 25% of the time. And so you're testing if it's different from a random draw of cards, whether it's different from all of them having a probability of 0.25. So you can change that default to whatever null hypothesis you'd want. So it could be a null hypothesis that none of the cards have any probability, in which case if you randomly draw cards, it's probably not going to be equal to that, but you could decide that. All options occurring with a frequency greater than 10 is an assumption of most standard chi-square analyses that there's at least some rate of probability for each of those, in which cases, if you don't meet that assumption, you'd have to do a different test. And D would be the case if you were doing a chi-square test of independence. And of course, with the goodness of fit, you don't have 2 groups that you're comparing. You only have 1 group against a null hypothesis. All right, so for the last one, which of the following does a paired sample t-test assume? Right, so for a paired sample t-test, like all standard t-tests, it assumes that the dependent variable or outcome variable that you're looking at is normally distributed. And so if it's not, there can be a violation of assumptions. Sometimes you have to do a different variation on the test. With a paired sample t-test, you're actually assuming that the observations are not independent. That is, there are two sets of data that are paired with each other. So one person gave 2 responses at 2 different time points, for example. The population mean would not be known with a paired sample t-test. That would be when you'd use a 1 sample t-test. And with a standard pair sample t-test, you are making assumptions that the standard deviation is equal for both groups. So if they're not equal, you sometimes have to do a different test to account for that as well. So I'm hoping that this review was helpful for you. If you do have any questions about the upcoming quiz, feel free to add that to the discussion or send any emails if you want to talk about anything related to the quiz. As always, I can always set up Zoom meetings with you. And if you want to review things, you'll also get to say hello to Raja as well. So Professor Raja will be able to help you out with the quiz as well, if you'd like. So I hope everyone is not going completely stir crazy, staying inside. You're all being safe. I know this has been a big adjustment, and doing the quiz online, doing everything online is very different from all of us, but I'm hoping that you're still getting to learn just as much as you usually would, even if we're not spending as much time running a whole bunch of analyses in R. So with that, I'll wrap things up and let me know if you have any questions that might come up.